Imagine a factory where thinking robots are working, not human hands. This is not a science fiction film, but Tesla's Fremont plant, where Elon Musk has started a new technological revolution. And this time, it's not just about automobiles. This change is challenging the very definition of human labor. Here, Tesla has quietly started limited-scale production of Optimus Gen 3 robots. The goal is to make 5,000 units. Each unit is being installed with more than 28 drive units, 2 superfast FSD chips, more than 1,000 mechanical parts, and a 360-degree sensor system that can read the world around. And then comes the most surprising part. Each robot is subjected to continuous testing for a full 72 hours before shipment, so that no flaw remains. But this is where the biggest question arises. Will these robots replace humans? Is Tesla creating digital laborers, not just machines? And what technologies has Elon Musk incorporated in them that make them not just tools, but a thinking worker? If you want answers to these questions, then subscribe to the channel right now. Because here we bring every update related to Elon Musk and his technology, first and in the most real way. Elon Musk's dream is no longer limited to cars. Tesla has now moved in the direction where every robot can become a worker, an assistant, and part of a system. Optimus Gen 3 is no longer just an experiment, it is a mission. Its production process at the Fremont plant has been designed so meticulously that every part, every actuator, every chip fits under a precise strategy. And this strategy is now going to spread to America's largest plant, Giga Texas, where the factory spread over 10 million square feet can become the manufacturing hub of Optimus in the next few years. On the other hand, Giga Mexico is also going to be ready by the end of 2025, which will further accelerate the global pace of this robot army. Now imagine if these two factories together can make 1 million robots every year. Will any industry, any sector, be able to survive this change? But the real magic behind all this is not just the scale, but the thinking that went into creating Optimus. Its modular design is such that every part, from the hands to the battery, can be replaced. Its muscles, i.e., actuators, are also the same as those found in the Model 3, just in a slightly modified form. This means that Tesla did not spend money on a completely new infrastructure, but used old resources in a new way. This is the reason why this robot is being made at a cost 10 times less than competitors like Boston Dynamics or Agility Robotics. You will also be surprised to know that its black and white color is not just a style. It is a special material coating that makes the robot lighter and more tolerant. The use of magnesium-aluminum alloy makes it 20% lighter than others, while its grip and strength are so much that it can lift up to 220 kilograms. Elon Musk's team designed it to be so lightweight and balanced that the motors are not overloaded, making it fast and reliable. But its outer layer is no less interesting. It's not just ordinary paint, but electrostatic painting technology has been used, the same technology that Tesla tested for its cars. This coating doesn't just look great, there's science behind it. The thin but extremely durable layer of paint protects the robot from moisture, dust, and electrostatic shock. This not only increases its life, but also reduces paint waste during production, a direct cost reduction. While other companies like Agility Robotics and Figure AI are still using traditional painting methods, Tesla's move clearly shows that it's not just working on the surface, but also on the inside. And it's not just the outside. There's something inside that might surprise you, too. The inside of Optimus is built with a honeycomb-like frame structure, a design that's not only lightweight, but also powerful. This design maintains structural strength while reducing weight, especially when the robot has to perform in difficult conditions. In comparison, other companies still rely on heavy aluminum frames that add strength but take away agility. And as for working with humans, Tesla has made a smart decision on this front too. Optimus's arms and elbow parts are covered with a soft TPU plastic to reduce the chances of injury in case of a collision with a human. Imagine if one day you knock on your door and there is not a human, but a smart robot standing there who never gets tired, never makes mistakes, and helps you with all your work with utmost efficiency. This is not fiction. Tesla is rapidly making this future a reality. Elon Musk's strategy is no longer just high-tech, but high-scale. Tesla is preparing to make millions of Optimus Gen 3 robots. And to do this, it is removing every obstacle that can slow down the speed of production. First of all, Tesla has simplified and made the manufacturing process very smart. Heavy, expensive, and complex parts are now being replaced by lightweight, durable, and modular parts. This has not only made the robot move faster, but its assembly time on the factory line has also been reduced considerably. Along with this, Tesla has also adopted the same method in painting and coating that it used with its cars: advanced electrostatic coating technology. This not only protects the robot's body from rust, dust, and shocks, but also maintains its performance for a long time. And since there is very little paint wastage in the process, it also reduces production costs. A question that is puzzling the world: can a machine think? Can it not just imitate humans, but also learn by itself? And if yes, then the day is not far when it will surpass humans as well. How does Tesla build the brain of Optimus Gen 3? And how is its quality and lifespan tested? The machine created by Elon Musk, Optimus Gen 3, is no longer just a robot, but a learning brain. Its brain is much more than a simple circuit board. It has the same Tesla FSD, full self-driving chip, that enables cars to drive on their own. But now this chip is putting human-like thinking, decision-making, and reaction into the robot. Optimus Gen 3 is not taught, it learns. How? This robot processes information from cameras and sensors, scans the 3D environment, and understands images the way a child understands new words. It is not limited to pre-programmed commands. It has an AI system that constantly improves itself from its experiences. And its training does not take place in an ordinary lab, but in Tesla's real factory, where every movement, every gesture of human work is recorded. Optimus reprograms itself by watching them. If today it learns to just pick things up, tomorrow it can learn to fold clothes, and the day after tomorrow perhaps to repair machines. Its brain is so fast that it can do millions of calculations in seconds, so much so that even a supercomputer of 10 years ago will seem old in front of it. But just being fast is not enough. It is also important to be durable. Each Tesla Optimus robot is not just sent to market straight after production. Behind it is a testing model that is probably unheard of in any robotic system before. Each unit is run continuously for 72 hours in different simulated conditions, as if it were a futuristic trial. Factory heat, warehouse dust, or home chaos, Optimus has to prove itself in every challenge. These tests are no ordinary checklist. They include torque pressure tests, software latency measurements, drive signal accuracy, sensor reliability, and performance checks at constant load. This ensures that the robot can last not just for a day, but for more than 20,000 hours or 10 years. Tesla has used materials like magnesium aluminum alloy and soft TPU plastic to make it lightweight, durable, and repairable. Its modular design means any part can be replaced quickly, making maintenance easier and eliminating the need to replace the entire robot. But the real game changer is the price. Elon Musk plans to make this machine available for less than $10,000, an AI-driven robot for the price of a mid-range bike. The question is no longer whether robots can do the work of humans. The question is, how long will it take for every factory, every office, and maybe even every home to have an Optimus? When will these digital assistants replace human hands? And are we ready to enter an era where machines will become our habit, not our need? How far along is Tesla in scaling up production of the Optimus Gen 3 robot? By May 2025, Tesla has pushed the humanoid robot out of labs and test rooms and into actual production. A pilot assembly line has been commissioned at the Fremont plant in California, with a target of 5,000 units in the first phase. But Elon Musk is not going to stop there. He says Tesla has already stored parts for more than 10,000 units. This is no small step, but the foundation of a massive plan being prepared for 2026, where Optimus will become a part of every industry, especially where the work is repetitive or dangerous for a human. But the path is not as straight as it seems. Optimus is not a normal machine. It has a level of AI that gives it the ability to understand its environment, adapt to it, and make decisions on its own. But building such a thinking machine at scale is a whole different challenge, whether it's the actuator system or the magnetic elements in the motors, which contain rare elements like neodymium and dysprosium. And this is where China comes into play, as 90% of the world's rare earth magnets come from there. China recently tightened export controls on these. This means Tesla now needs special licenses for every shipment, and the slightest supply mishap could halt the entire production line. Elon Musk himself admits that this level of innovation carries a lot of risk, because it's not just a machine that's being built, it's an entire future. One small mistake, a sensor glitch, or a minor bug in the code can ruin everything. But still, Tesla isn't stopping. The company plans to build more than 50,000 Optimus Gen 3 by 2026. And that number could go up to millions every year in the next 4 to 5 years. That means we are standing at a turning point where history will be divided into two parts. One, when humans used to work, and second, when humans taught machines how they can work better. By May 2025, Tesla has pushed the humanoid robot out of labs and test rooms and into actual production. A pilot assembly line has been commissioned at the Fremont plant in California, with a target of 5,000 units in the first phase. But Elon Musk is not going to stop there. He says Tesla has already stored parts for more than 10,000 units. This is no small step, but the foundation of a massive plan being prepared for 2026, where Optimus will become a part of every industry, especially where the work is repetitive or dangerous for a human. But the path is not as straight as it seems. Optimus is not a normal machine. It has a level of AI that gives it the ability to understand its environment, adapt to it, and make decisions on its own. But building such a thinking machine at scale is a whole different challenge. Whether it's the actuator system or the magnetic elements in the motors, which contain rare elements like neodymium and dysprosium. And this is where China comes into play, as 90% of the world's rare earth magnets come from there. China recently tightened export controls on these. This means Tesla now needs special licenses for every shipment, and the slightest supply mishap could halt the entire production line. Elon Musk himself admits that this level of innovation carries a lot of risk, because it's not just a machine that's being built, it's an entire future. One small mistake, a sensor glitch, or a minor bug in the code can ruin everything. But still, Tesla isn't stopping. The company plans to build more than 50,000 Optimus Gen 3 by 2026. And that number could go up to millions every year in the next 4 to 5 years. That means we are standing at a turning point where history will be divided into two parts. One, when humans used to work, and second, when humans taught machines how they can work better. Now the question is, if all this is so complex and risky, then why is Tesla moving ahead with so much confidence? The answer lies in the experience Tesla has gained over the past decade with its gigafactories, battery technology, and autonomous driving. Elon Musk and his team know that making a new technology scalable is the real success, and that is what is being done with Optimus Gen 3. Every new data point, every assembly run, every feedback is constantly improving this robot. And when it is made in millions of units, not only will its cost decrease, but its accuracy, reliability, and ability to collaborate with humans will also reach new heights. Tesla's planning is not limited to factories only. Elon Musk dreams that these robots will go to schools, hospitals, homes, and space missions where it is difficult for humans to reach or survive. And if this dream turns into reality, then the way we work will completely change. Now imagine, are we heading towards a world where humans and robots will work in the same team? If you want to be a part of this technological journey, subscribe to the channel now. Like the video and press the bell icon so that next time history is written, you are the first to know.